Hi, and welcome to this video on binomial expansion with partial fractions. Now, here we have a function of x, and it's minus 9x on the top, 3 minus x squared on the denominator, and we're told it can be written in this form, two partial fractions. Now, let's just talk about why they're telling us this form very quickly. Well, if we look here, the power on the top is x, and I'm going to have x squared, so we know it's not going to be top heavy. It's always worth checking because they don't have to give you this form. And if it's top heavy, you're going to have a constant or maybe more at the start. So let's find the values of a and b. Well, so what we're going to do is we're going to try and make if we were going to add these, we'd be making common denominators. So first of all, we've got to make them have common denominators. So to do that, I'm going to be multiplying this fraction here on the left by another 3 minus x. The b already has this denominator, so I don't need to change that. And on the left, I have minus 9x. So that is a true statement based on the information we're given up here. Now, if that's a little bit unclear, you need to watch an earlier video on partial fractions. So what we can do here, so if we start subbing in some values, so how can we eliminate these a's? Well, we can do that when x is 3. So when x is 3, I get minus 9 times 3, that's minus 27. That's been eliminated, and I get b. So that's true. Well, there's nothing else I can eliminate, so let's compare coefficients. Let's compare the coefficient of x. Well, on the left-hand side, I have minus 9. If I was to expand this, I get minus a, so therefore a must be 9. So I'm just going to pop this up here because then I can get rid of this text below. So we have minus 9x all over 3 minus x squared is equal to a, 9 over 3 minus x, plus, oh, shouldn't have done that, look ahead, minus 27 over 3 minus x squared. Okay, so what I'm going to do is just quickly get rid of all of that. Just delete that. There we go. Right. Now, what it's asking me to do now is hence or otherwise, so use it, find a quadratic approximation. So that basically means go up to x squared for this. Right, well, we've got to work out the expansion of this term and then take away the expansion of this term. So 9 over 3 minus x, well that's the same, isn't it, as 9 times 1 over 3 minus x, which is the same as 9 times 3 minus x to the power of minus 1. So what we're actually expanding is this 9 lots of 3 minus x to the power of minus 1. So if you have a power that is negative, you have to use the alternative formula, the 1 plus nx, etc. But that only works if this value here is a 1. So what we have to do is factorize. So I'm going to write this out. So this is the same as 9. We're going to factorize for 3, and that would give me this. But if you remember, whatever I factorize for has to take that power. And I explained that to you before using indices like this. So what's happening here is every single part of this is actually being raised to the power of 3. If you think about it, it's 3a squared b times 3a squared b times 3a squared b. So the 3 is being cubed, the a squared is being cubed, and the b is also being cubed. So when we factorize for something, basically what's happening is this. So when we factorize, we're getting this sort of problem. and now everything is actually being raised to the power of minus 1 because all we're doing is rewriting this bit inside the square brackets. I'm just going to get rid of that because I'm going to need some space in a second. Okay. Well, what is 3 to the power of minus 1? Well, that's a third. So 9 times a third of 9 is 3. So this is actually what we have to work out. Excuse me. So 3. I'm going to open a big square bracket here and do all my expansion. So 1 plus n. Well, n represents my minus 1, and then the x is this term here. So we've got minus x over 3. Then we have another n minus 1 over 2 factorial, which is 2. And then my x term again, but this time it's being squared. So I get 3 lots of 1. Minus and a minus is a plus, x over 3. So what's going to happen here? That's a positive. That's a 2. 2 divided by 2, that's going to cancel out. And minus x over 3 times minus x over 3 is x squared over 9. And we have 3. So expand this now. 3 plus the 3 and the divide by 3, they're going to cancel out. And 3x squared over 9 is the same as x squared over 3. Okay, so I'm just going to underline that. In fact, I'm going to draw a box around that because I'm going to need that in a minute. As you can see, I've run out of screen. So what I'm going to do is just make it small. Right, let's have a look at the next bit. So let's go purple. So this time we've got the 27. So 27 over 3 minus x squared. That is the same, for the same reasons I explained earlier, is the same as that. Right, okay, this isn't set up either, so we've got to factorize for the 3, just like before, and that takes on that power. This is now a ninth, 3 to the minus 2, so 27 divided by 9, or 27 times 1/9, that is 3 again. And then I'm going to start my expansion. So 1 plus n, and then I have my x value, plus n again, times n minus 1, over 2 factorial, which is 2, and then I can just squeeze this in here, my x term this time being squared, square bracket. So what do we have? 3 lots of 1. Now minus and a minus is going to be a plus again, but I've got 2x over 3. That's 6. 6 divided by 2 is 3. And I've got 3 lots of x squared over 9. Because I've written like this, I'm just going to do another line of working to tidy this up. So I've got 1 plus 2x over 3. Don't be tempted to start cancelling early, just get it all tidy first. Now, I could divide both of these by 3, so I get x squared over 3. Now I'm going to times by 3, so I get 3 plus 2x plus x squared. And I'm going to get that blue out again and draw a box. So, I've expanded this one up to x squared. I've expanded the second one up to x squared. Now all that's left to do is minus them. So 3 minus 3, that's 0. 1x take away 2x is minus x. X squared over 3 minus x squared, well, let's think of that as 3x squared over 3. So it's 1/3, or take away 3/3 is minus 2x squared over 3. So we have now expanded this term up to and inclusive of the x squared term. We did that by writing them as partial fractions, then using the alternative formula for each one, and then combine them. It's a lot of work. For 6, 7, maybe even more marks in a test. It's definitely worth it. Good luck, guys.